Okay, gentlemen, today we're learning about radical expressions for 5-6. And we're first going to talk about the product property of radicals. For any real numbers a and b, and any integer n being greater than 1, you have the following rules. 1. If n is even and a and b are both non-negative, then the nth root of a times b equals the nth root of a times the nth root of b. So what that means in a nutshell is if I have the cube root of 6 times 4, that can be broken up into the cube root of 6 times the cube root of 4. And then from there we would be able to simplify as needed. And in this case, there's not much to simplify. But you can break down products inside of radicals. And the same thing works if it's odd. And I'm sorry, this should have been a square root, because that was for even. Now it works the same way for odd. If I have the cube root of, let's say, of 5 times 8, that breaks up into the cube root of 5 times the cube root of 8. And then from there, you can go ahead and simplify as needed. And again, this is a square root up here. Okay? So let's continue. The quotient property of radicals is about the same thing. For any real numbers a and b not equal to 0, and any integer n greater than 1, the nth root of a divided by b can be split up into the nth root of the numerator, which is a, and the nth root of b, which is the denominator. So you can split them up as so. If I have the square, or the cube root of, let's say, 8/12. This breaks down into the cube root of 8 divided by the cube root of 12. And we'll talk about simplifying that a little bit later in the lesson. So let's review the concept summary overall, how you know when you have simplified a radical form. Okay? And the first one, if we think about it, the index is as small as possible. If you can reduce that index at all, that's what you want to do. Number 2, the radical contains no factors other than 1 that are nth powers of an integer or a polynomial. Number 3, the radicand contains no fractions. And last but not least, no radicals appear in the denominator. Whenever you have a radical in the denominator, you have to complete something called rationalization. You must rationalize. And you rationalize the denominator by multiplying both the numerator and denominator by the radical in the denominator. So for example, what does that mean? If I have, let's say, 3 over radical 2, in order to get the conjugate of this radical 2, I'm going to have to multiply by the radical which will cancel out the denominator. So in this case, I would be multiplying by square root of 2 over square root of 2. 3 times square root of 2 is 3 square root of 2 over square root of 2 times square root of 2 is 2. Whenever you multiply the same radicands raised to the same index together, you cancel out the radical, and the radicand comes out as one unit. Let's see another type of conjugation. Let's say I have 5 over 1 plus the square root of 3. When I have a binomial with a radical attached to it in the denominator, I'm going to go ahead and multiply by the conjugate. And the conjugate in this case will be 1 minus the square root of 3. 1 minus the square root of 3. And from here, you go ahead and distribute as normal. 5 times 1 is 5 minus 5 times negative square root of 3 is negative 5 square root of 3 over 1 times 1 is 1. 1 times negative radical 3 is negative radical 3. Radical 3 times 1 is positive radical 3. And radical 3 times negative radical 3 is going to be a negative 3. So in the end, this will equal 5 minus radical 3 over negative 2. And that is how you rationalize a denominator if there's a binomial in the denominator. Now, sometimes you have to rationalize expressions, but it's not so easy as just multiplying the square root. Let me explain what I'm talking about. Let's say I have 5 over the cube root of 6. Okay. In order for me to cancel out this denominator, I'm going to have to multiply the cube root of 6 times something where the cube roots cancel out and I'm left with 6 in the denominator. So the way I like to think about it is as such. We know that because we have an index of 3, we're looking for sets of 3. So in order to pull out 1 6, I'm going to have inside of this radicand with an index of 3, I'm going to have 3 6s. So what can I multiply to this cube root of 6 so that in the end I have 3 6s? Well, it's very simple. If I have 1 6 under this radical 3, all I got to do is multiply both the numerator and denominator by the cube root of 6 squared. Cube root of 6 squared. Again, why? Well, because I have 1 6 inside of radical 3, so I need another 2 6s inside the radical 3, so that when I multiply, I get the following. 5 times cube root of 36 over the cube root of 6 to the third. Now, how did I get that 3 as an exponent of 6? Well, when I multiply 6 times 6, I multiply the bases and I add the exponents. So in the end, this would come out to equal 5 radical 3 36 divided by 6. Okay? And 36 cannot be broken down. That gets broken down to 9 times 4. So that means you have 2 3s and 2 2s. You have no sets of 3, and you are done. Okay, so now that you know how to conjugate, let's go and take a look at some examples. So in the first example, we have the square root of 16 times p to the 8th times q to the 7th. I always like to go one by one. So for this example, I have a square root of 16. You're looking for the positive root. If I wanted a plus or minus root, I would go plus or minus. Okay? So square root of 16 is 4. Square root of p to the 8th, well, what is 8 divided by 2? That's 4. It goes in 4 whole times, so that's p to the 4th. And q to the 7th, okay, 7 divided by 2, you're going to get 3 sets of 2 q's, and you're going to have left over square root of 1q. Okay, so hopefully that makes sense to you guys. Let us continue. Now, what if I have, for example, 2 here, the square root of x to the 4th divided by y to the 5th. Well, if I have the square root of x to the 4th divided by y to the 5th, I'm going to have the square root of x to the 4 divided by the square root of y to the 5th. The square root of x to the 4th comes out to be x squared divided by, okay, let's think about this. Square root of y to the 5th is going to be y squared times the square root of y. But I have one tiny problem here. I have a square root of y here in the denominator. So that means I have to rationalize. So in order to rationalize this, it's very easy. I have a square root of y, so that means I need 2 y's to pull out one y out of the radical. So I'm going to multiply by radical y to both the numerator and denominator, giving me x squared times radical y over y squared times y, because y squared times square root of y times square root of y equals y. And in the end, I'm going to have x squared square root of y divided by y cubed. And there you go. Your answer is done. All right, let us proceed. For example 3. Now in this case, we're going to get a little bit tougher. We're going to have the 5th root of 5 divided by 4a. So this is going to break down into the 5th root of 5 over the 5th root of 4a. Now, I need to get rid of the 5th root of 4a here. So we have to think about, what can I multiply to the numerator and the denominator so that the denominator is just a whole value? It gets rid of the radicals. Well, let's think about what radical 5, the 5th root of 4a really means. 4 can be broken down into 2 times 2, and then you have times a. So that means that in this 5th root, you have 2 2's and 1a. You have 2 2's and 1a. So that means that I have to multiply the 5th root of 2 cubed times a to the 4th. Again, that's 2 cubed times a to the 4th. Why? Because I had 2 2's, so I needed 3 more 2's to pull out 1/5 root. I had 1a, so I need 4 more a's to pull out 1a from a 5th root. So now we're just going to go ahead and multiply. The 5th root of 5 times the 5th root of 2 cubed a to the 4th is going to be the 5th root of 40a to the 4th. I cannot break that down, and I don't need to, because it's not in the denominator, so I don't need to rationalize it. We don't have any sets of 5 here, so that's simplified. Now the denominator, we've got the 5th root of 4a times the 5th root of 8a to the 4th. Well, think about why we did this. Since I have 5 2's here, I've got 5 2's here. I can take out a 5th root as 2. Since I have 5 a's now, I can take out an a as a fifth root, and that is my final answer. Now, when we're multiplying radicals, just like regular variables, you can multiply anything together. Just remember that the variable exponent rules do apply. So if I multiply the same bases together, you keep the base and you add the exponents. So for example, 4, we got 6 times 3, which is 18, times the cube root of 9n squared times 24n. Now in this case, I like to really simplify things instead of expand them to break them down again. So what am I talking about? Let's break down what's inside the radical. Let's break down the radicand to its prime factors. So I've got 18 times the cube root of 9 times 9 is 3 times 3. 24 is 3 times 8, which is 2 times 2 times 2. And then I have 3 n's. Now when you break it down like this, it's very simple to figure out the answer. Since I have a cube root, I'm looking for sets of 3. So I have 18 times, since I have 3 3's, I pull out a 3, times, since I have 3 2's, I pull out a 2, times, since I have 3 n's, I pull out 1 n, and my answer would be 108 n. And you are done. You are simplified. So let us continue. Now if you can see here in red, I'm going to go ahead and highlight it as well. Only like radicals can be added and subtracted. Just like terms. If you remember, if you have 5x plus 3x, that's going to be 8x because you have x to the power of 1. If you have 2x squared plus 3x squared, that's going to be 5x squared because x is raised to the second power. You have the same variable and the same exponents, so they're like terms, so you can add them. Just like that works, you're going to apply it to radicals. So for example, here in 2 times radical 12 minus 3 times the square root of 27 plus 2 times the square root of 48. None of these radicands are equal, but we can break these down so that we can have like radicals, and then we can add them together. So let's go ahead and start with, let's go ahead and switch this back. So let's go ahead and start with this guy right here. So I got 2 times the square root of 12, but the square root of 12 breaks down to 4 times 3. So the square root of 4 is 2. So 2 times 2 is 4 radical 3. Minus, you got 3 times radical 27. But 3 times radical 27 can be broken down into 3 times radical 9 times 3. The square root of 9 is 3. 3 times 3 is 9, radical 3. And last but not least, I got 2 times square root of 48, which is 16 times 3. So I have 2 times the square root of 16, which is 8, radical 3. If you noticed here, I tried very hard to break down the original radicand into a perfect square and then the leftover number. Perfect square and the leftover number. Perfect square and the leftover number. If you cannot break it down into the perfect square, that's okay. You just go ahead and break it down like you can, the way you understand how to, and then just pull out sets of 2. So for example, let's say I have the square root of 48 here, and I don't remember that that's 16 times 3. I can break this down to 2 times 24, 2 times 12, 2 times 6 and 2 times 3. Remember, we're dealing with a square root in this particular case, so I can take out one value for every set of 2. So I have a 2 and a 2, which comes out as a 2, a 2 and a 2, which comes out as a 2, and I have a leftover of radical 3, so that's 4 radical 3, and that's how I got this answer over here of 8 radical 3, because 2 times the 4 gave me 8. So now that I have all radical 3's, I can go ahead and add this. 4 radical 3 minus 9 radical 3 is negative 5 radical 3. Negative 5 radical 3 plus 8 radical 3 is 3 radical 3. And you're done. Now when we're multiplying, we're going to multiply as if they were variables as well. We're going to go ahead and FOIL. So 3 radical 5 times 2 is 6 radical 5 times, or plus, 3 radical 15 minus 4 radical 3 minus 2 radical 3. So the only things that I can add here potentially are okay, I'm sorry, and I apologize greatly. I made a little bit of an error here. When I multiply radical 3 times radical 3, it's not going to give me radical 3. It's going to give me 3. But let's go ahead and do that again because I don't want to confuse anybody. So let's start from the beginning. 3 radical 5 times 2 is 6 radical 5. 3 radical 5 times radical 3 is 3 radical 15. Negative 2 radical 3 times 2 is negative 4 radical 3. And negative 2 radical 3 times radical 3 is negative 2 times 3. Sorry about that. Radical 3 times radical 3 is 3. So this breaks down to 6 radical 5 plus 3 radical 15 minus 4 radical 3 minus 6. You cannot break down any of those radicands, so you are done. Let's try another one. Okay, so here I got 5 radical 3 times 5 radical 3, which is 25 times 3, because radical 3 times radical 3 is 3, plus 30 radical 3 minus 30 radical 3 minus 36. So here I have 75. 30 radical 3 minus 30 radical 3 cancel, minus 36, and I get 75 minus 36 is 39. Now, let's conjugate again. We cannot have a radical in the denominator. So I'm going to multiply both the numerator and denominator by 5 minus radical 3. 5 minus radical 3. Okay, does that make sense? You cannot have radicals in the denominator, so you must multiply both the numerator and denominator by the conjugate. Remember that. Let's go ahead and pull this guy over here so you can see what's happening. So over here, we've got 1 times 5, which is 5. 1 times negative radical 3 is negative radical 3. Minus 5 radical 3 plus 3. Because a negative radical 3 times a negative radical 3 is a positive 3. Let's go ahead and complete the denominator. 5 times 5 is 25 minus 5 radical 3 plus 5 radical 3 minus 3. So now let's simplify this. The numerator, I've got 5 plus 3, which is 8, minus 6 radical 3's, because a negative radical 3 minus 5 radical 3, you add like terms. When the signs are the same, you add and keep the sign, negative 6 radical 3. And down at the bottom, negative 5 radical 3 and positive 5 radical 3 cancel out, and I've got 25 minus 3, which is 22. And to simplify this one last step, I can take a 2 away from the 8, the 6, and the 22. So let's go ahead and divide 2 from both top and bottom. So I'm going to be left with 4 minus 3 radical 3 over 22. And that is the lesson on radical expressions. Thank you very much, and have a great day.